Okay, so the next question is, what is the usage of these structures? Now, when I had created my array, let me get rid of this index for now. I don't need that, right? So in fact, we use my array. If I wanted to use elements of the array, my normal choice of syntax is to use some kind of index, right? So for instance, if I say I wanted to display std cout and say first element is, right, just kind of silly thing, and I wanted to print my array element, I need to specify index 0, and that basically makes it also have new line at the end here, right? But this type of syntax allows me to access individual elements of the array. Basically, square bracket attached to the name of the array, and specify which element 0, because remember, these guys right here, their indices are, so this guy right here is 0, this is 1, right, and so forth, 1, 2, 3, and so forth. So these are the actual indices that I've was able to initialize, and this is the index of the first or initial element of my array, right? So likewise, I could have changed it simply by saying equals whatever it already has and multiplied by 100, right? So this is how we can use array syntax in both write and read the value. So this basically takes 10, multiplies it by 100, which becomes 1000, and so this element now becomes 1000 as a result of this assignment, and then that should be showing 1000. But the bottom line is that we pretty much have not too many other choices but to use the index to be as direct as possible to access elements of the array. How about point? With point, right, and here's my point right here. The definition of my point is here in this header file, which is now included, right? So it has the elements of this aggregate data structure pixel have names, right? So if I wanted to do something similar and say that x pixel x is and the name that I gave to my structure in memory is called point, because that's the variable name that I used. So if I wanted to access x, I need to use the member resolution operator, which is the dot, right? So when I say I want to display this x from my pixel, which is now in memory, right? So say this was this is pixel, right? Pixel point, that's its location, and so this is x, and this is y, and this is red, green, and so forth, right? So if I wanted to display the value of x, which is now part of this data structure in memory, all I need to do is basically, instead of using an index, which we use with arrays, here I just use the name, right? So if I wanted to pixel y, display pixel y coordinate, I would do something like that, right? So, and then similarly with colors and so forth. If I wanted to change them, right, I would just use the same notation to say equals x equals y, right? So I could make it x and y the same value, simply by using the dot syntax, which is a member access operator. Okay, member access operator is the dot, and it's very simple. So now you say that I still have my x's and y's in memory, but when I create them, they become part of the same structure. This structure was given name point, and now we use it to access individual fields, the data fields in the structure. Okay, so that shouldn't be, that should not propose any kind of problem. But before we take a break, I would like to say that perhaps this is a relatively long data structure, right? So it has not one but two integers. In fact, if this was some sort of point in 3D space, it would also have x, y, and z coordinate, and it could potentially include other components. So it can be a lengthy data structure which includes a lot of things. In that case, if I wanted to add a function, say update pixel, and if I wanted to give, if I wanted to write a function which would update a pixel, so I would say pixel, its argument is a pixel, px, for instance, right? I could name it px. But perhaps I don't want to, in order to update something, I don't want to make a copy of it, because when you say pixel px, if I wanted to somewhere here, if I wanted to say update, call this function update pixel, which I just declared, right? If I was call it for point and pass the point to it, then what would happen is that the copy of this pixel in memory, now it's being already kind of like updated on this line, but doesn't matter. Like this gives you what's inside my pixel, all of these values of different data types. But its copy, its physical copy, would be manufactured before the update pixel is called, and therefore, if we have this function named update pixel, right, which takes pixel as a parameter, an exact copy of this pixel would have to be manufactured in memory with all of its fields, right, just whatever these fields are, and the copy is, the physical copy is made, and then update pixel would get access to the copy of this pixel. And as soon as update pixel returns, its stack frame is gone, right? So this will be gone completely, and we return back to main. So perhaps this is not a good version of the update. And back we go to say, well, perhaps we need to pass the pointer to pixel, right? So instead of passing a copy of the pixel, pass an address of the pixel, and simply by saying take the address of the point, and so have the update, right? So instead of passing point by copy, we simply say, oh, let's ask the point, what's your address of the point, which is basically a small value like this with this crazy, crazy value of the actual memory address that points to the location of this object in memory. And so when update point is invoked, it's actually using in its local space a pointer to our structure. So again, why would you use a pointer to the structure? Because you don't want to duplicate this. In fact, you really cannot duplicate it because this intends to update the pixel. Well, let me again demonstrate. Perhaps what I could do, I could say pixel x equals, I don't know, 0, right? And then pixel y equals 0, and I can say that pixel red is now 1.0 f, and likewise I could say green is also 1, and blue is likewise. There's only one little problem to remember. You see, when I declare a point in my directly as a variable, that variable, of course, is not a pointer, it's just a name of the structure in memory, right? So we said that this structure that we created in our main function, name point, it essentially gives us access to this structure in our local memory. However, when we pass it by pointer, remember that pointers have to be dereferenced before we can use them. If we want to use the pointer which stores the location of our structure in memory, they have to be first dereferenced, and the dereference, of course, is the asterisk in front of it, and we need to also use parentheses because we want to disambiguate that first we want to dereference the pointer, and then we would like to essentially use that pointer, right? So this is our pointer in memory. We want to use that pointer to access the structure, and then we want to use this component which is X or Y or red, green, and so forth, right? So that would be the actual syntax that you have to use with pointers. However, programmers decided that with pointers to structures, in order to access individual members of the structure, such as X and Y and so forth, this becomes kind of ugly, like not very, looking cumbersome. So they decided to, and this syntax is available, you can use it. But most people, in most cases, will use the arrow operator. The arrow operator does exactly that. It dereferences the pointer and gives us access to the actual component of that structure, right? So normally when you see the arrow operator, it's simply called pointer to member dereference operator, which basically takes, on this side, you have the pointer to a structure, such as pixel, and then instead of using the dot operator, if you have a pointer, you use the arrow operator, and the arrow operator gives you access to your members of the structure that you're dealing with. So, and of course, to be able to compile everything properly, I need to make sure that the syntax that I'm using is proper, and that is what we need to do. One final note before the break is this. Of course, we've used pointers to integers and characters and other types of pointers. But pointers to integers, if I did created, say, integer x equals 0, and then integer pointer px equals address of x, right? So px is an integer pointer. There is nothing that you can do like that with px here, okay? This syntax is available only with structures. With fundamental data types, there is no syntax such as this. So the arrow operator is available only for structures. For normal pointers to fundamental data types, all you can do is just dereference the pointer. Okay, so that is something that you could use, but with pointers to structures, remember that you have two choices: either dereference it, but then you need to use the parentheses due to the precedence of operators, or use the arrow notation or the arrow operator with pointers to access individual components of your structure.